All right, take two for today. So we are actually trying to get through our probability unit. We're starting on it. This is getting close to the end, and it's always fun because usually when I start recording, that's when people decide to get louder for some reason. All right, again, don't forget hit like, hit subscribe, hit the bell. All right, finding a number of outcomes. Multiply the possible number of outcomes used in the experiment. That's really it. Okay? So, this example, you rolled two dice in a board game. So, how many outcomes are there? All right. How many sides? This is regular dice. My D&D people, my other people that use those like 25 sided number cubes. I know, but we are just dealing with regular stuff right here. Six. All right. So a regular cube has six. Yes. I know there's not a 25 sided die, but there is some that are like very much multiple, right? All right. Yeah. We'll talk about it later. Y'all can fill me in. All right. So we're going to multiply our 6 times 6. All right. So, all right. Are you ready? Because this is going to be really difficult. Okay. For those that try to use your phone to cheat on the test, you may want to try it now. 6 times 6 is. Wow. All right. You flip three separate coins. Okay. Three separate coins. How many possible outcomes are there? Well, on a regular coin, each coin has two outcomes, head or tails. Okay. Whether it actually has a head or has a tail or it's two sided, you know. So we multiply that's two and the second one and the third one. And yes, we do get eight. Okay. So that is kind of what we need to get to. Now, it's funny, because last year or last semester I redid this. Now I'm redoing it again. We have to know this part to be able to get to the next part. And what's very odd is that some people cannot grasp this idea before we start doing the next part. Okay, so maybe that's the emphasis. I don't know. All right, to the back. So theoretical probability. Theoretical means are what ifs. Okay, some of y'all go, well, what if this happens, and what if this happens, and what if this happens? What if people actually are quiet and pay attention and all take notes diligently, all in one certain Algebra 1 class? It's never going to happen, ever. But what if? Because that's in theory. All right. So here is the math definition: favorable outcomes over possible outcomes. And then here's the Jeffries version: basically what we want over what we have. Okay? And when we start doing this, some of y'all are like, I love this stuff. Yes, this should be a review. You should have seen this somewhere along the way, whether you remember. Depends on your chemical romance that you have, if those brain cells are still with you or not. All right. So now, I don't know, and we have to keep our probabilities very small and elementary, but I know y'all get together with your friends and have a good time, and your favorite game is to choose crayons out of a bag. All right, so we have 4 plus 1 plus 2 plus 5. So that's 5. So we have 12 crayons. Now, crayons, not crowns. Crowns are something that you wear on your head. Crayons. All right, so we're going to, each one of these, our denominator is going to be 12 because that's what we have. We have 12 crayons. 12, 12. We got 12 here. We got 12 here. Well, let's you're getting ahead of me there. High speed. The question was, do we put one on red? Well, let me look at it. All right. So, what we want a red crayon. How many red crayons we have? One. Okay. That's going to be it. That is because that doesn't reduce anymore. Okay? Wow. All right, green crayons. Well, we have 4 of those. Now, if you're not good at simplifying fractions, use the calculator, the N over D button. 4 over 12 should be 1/3. It's a green one. Oh my gosh. 2 blue ones. Yeah, 1/6. All right, not yellow. So that's everything but yellow. Well, let's see. We have, well, there's only 5 of the yellows, okay? So if there's 5 of the yellows, there's 12 total. How many of them are not yellow? 7. Yeah, we don't want the yellow ones. Okay, it's kind of like I don't know if y'all have Skittles or M&Ms and stuff that y'all. Some people only eat certain colors of Skittles. Okay, that's okay. I I don't necessarily agree with it, but if it makes them happy, then they can only eat their orange and red Skittles. That's totally okay. Just share the other ones with us people that eat all of them. Huh? All right. Are we good with 1 through 4? Okay, good. All right. Again, here we go. I know a lot of y'all spend such a great time spinning a spinner. Woo! Parkour. Now, all right. So here's my numbers 1 through 15. All right. So we have 15. So we know our denominator is going to be 15 when we start here on number 5. All right. Now, the probability of when we spin it, it lands on a 15. How many 15s are listed from 1 through 15? 1. Okay. Believe it or not, I've had people say, no, there's 15 of them. No, there's only 115. Okay. This is like back in the good days of football where people didn't have the same number. Sorry. That's an old person thing. All right. So we know we have 15. The odd numbers. Well, One, that's the wrong color. And by the way, if you can't see these, listen, I can't see these in my head. I've got random movie quotes and, yes, other stuff in my head that I cannot, this won't fit. I have to write it down. Okay. And some people kind of, again, picked on me for being a math teacher that can't do math in their head. I'm like, okay. Yeah. 1, 2, 3, 4, 5, 6, 7, 8. All right. So this happens 8 over 15 times. Now that doesn't reduce. So we just leave it. All right. Not 5. Everybody is invited to the party except for number 5. Number 5 is like Fregley from Diary of a Wimpy Kid. If you know that movie or book series, you know what I'm talking about. Yes. Wait, for which number? We're not on 8. We're on 7. All right, so how many numbers are not 5? Yeah, there's 14 of them. Yeah. All right. Now we're on number 8. It says less than 5. So here's 5. How many numbers are less than that? 4. It didn't say less than or equal to, it just said less than. Yep. Ooh, a multiple of 5. Some of y'all are, what does multiple mean? That means if you did your times tables and you did 1 through 12 for 5, what numbers would be at the far right column for that? Yeah. So the only multiples of 5 are 5, well, 10, and 15. Because 5 times 1 is 5. Not factors, these are multiples. This is what you get after you multiply. Okay, so this happens 3 out of 15 times, which does reduce. Yeah, it does reduce. See, it's. Mm-hmm. All right, a number greater than 8. So here's 8. Yep. So, so 1, 2, 3, 4, 5, 6, 7. All right, so 7 over 15. Here's what's even funny. We're finding the probability of this stuff, and it's like if we were to play this game of spinning the spinner, okay? Like if you're playing chutes and ladders or eels and escalators. All right, number 11. Numbers that are less than 16. Yes, and that is 1. There is a 100% possibility that you're going to get a number less than 16. Okay, now don't ask me about odds and stuff like that. Odds are like something totally different, and I forget the formula. I have to Google it and stuff like that. All right. Sorry, yawning. Now, probability that a number is greater than 16. Kind of like I had that student one year that I had to email their parents and I said, hey, listen, if they continue on what they're doing right now, they're going to have to make 175 out of 100 on the final to pass this course. Oh yeah, they did. It was also the third time they had been in that algebra class. Yeah. Hello. All right. So that's our lesson. We have a practice uh, paper that we're going to work on, and we're going to go over that. All right. Don't forget, hit like and subscribe to the bell. Good stuff, good things. Roll Tide.